Errors, your basic right when you are working in the laboratory. Correct, you may get the answer, you may not get the answer, you don't get the result, but errors we all commit. हमारा परम सिद्ध अधिकार है कि हम laboratory में errors करें. Okay, so errors we all do. We may not do the experiment, but errors we all do. So in this presentation, we are going to learn about what are errors and what are the different type of errors. So my name is Dr. Ina Sheikh, back with you again to clear some more basic concepts of chemistry. Today we are going to study about errors. So let us now quickly start. First of all, you should know the difference between error and uncertainty. Uncertainty means you are not sure of the answer. We all are not sure of the answers, correct? When you work in the laboratory, you are never sure of the answer. You show the beaker after you get the pink color of phenolphthalein, you show the beaker to the teacher and your face is like, is it correct? And the teacher also says, yes, it is correct. Okay, then you are sure, it's correct. But this uncertainty always remains with us. You cannot remove uncertainty. Okay, so this is the difference between error and uncertainty. Uncertainty means not sure, not very sure. Okay, so this uncertainty remains always with the answer. Okay, you do all the precautions, you take all the precautions told to you by the examiner or the teacher in charge, but uncertainty would always be there. But error you can reduce. For error, mostly you should know the true value. If you know your answer was supposed to be 10 and you are not getting 10 means there is an error. If your answer is 10, you are getting 10 means no error. Correct? So for error, you need to know the true value. For uncertainty, we need not know the true value. Okay, so uncertainty is always there. Uncertainty you cannot make 0. Error I can make 0. Okay, this is the difference between uncertainty and errors. There are 3 types of errors. Okay, determinate error, indeterminate error, and gross error. There are 3 types of errors. What are these? We are going to study in details. First of all, you should know what is gross error. I'll teach you gross error first and then I'll teach you these two. Achha, determinate error are the errors for which you know the source. You know from where the error has come. Okay, you know from where the error has come. Are determinate error. Indeterminate error are those where you do not know from where the error has come. You do not know the source. And for gross error, you know the source, and the error is huge. So huge that you have to reject and do the experiment again. I'll give an example. Suppose you are doing titration, you got the pink color, you are coming near to your teacher in charge, and in between somebody came running, people go on running in the lab without reason, I don't know why, but somebody came running to you and there is a clash and your beaker fell down. Okay, so you cannot show the answer now, you have to repeat the experiment. If suppose you are in between the experiment, like in gravimetry, you prepare the compound and you keep it in the oven for drying, correct? You do the experiment for 3 hours. After 3 hours, you keep the compound in the oven for drying. After drying, suppose you are coming to the balance for taking weight of your compound, and again in between somebody came running to you, clash, your compound fell down, you cannot do anything. The only thing you do is chapo, right? Copy somebody's answer. This is what you can do, or repeat the experiment. Okay, so in proper systematic thing, if you see, what you have to do is you have to repeat the analysis. So whenever you come across gross error, you commit gross error, you have to repeat the analysis. Okay, you cannot continue with your result. You have to repeat the analysis because everything has gone. A big blunder is a gross error, a huge error that is made. Fine. So now let us learn the difference between determinate and indeterminate error. What are determinate error and what are indeterminate errors? A very favorite question of the examiner where you are asked to give the points of difference between determinate and indeterminate error. Determinate error are those for which the source is known. You know the source. For indeterminate error, you do not know from where the error has come. These errors are of large magnitude, big errors. These errors are of small magnitude. These are small. Then these errors are unidirectional. What is the meaning of unidirectional? Means either your result is going positive, 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 or your results are going negative, negative, negative. Means my reading was supposed to be 10, but every time I'm doing the titration, I'm getting 10.5, 10.6, 11, higher side. Or I'm doing some mistake where my result is always coming lower than what I wanted. So 9.6, 8.6, 8.9, 9, correct? So my all results are going lesser in one direction. So either it would be negative type or positive type, means it will always be in one direction. Here anything can happen, both possible. It can be positive also, it can be negative also. Anything is possible because you do not know what it is, from where it has come, so anything is possible. The next point of difference between these is these errors can be eliminated. These errors can be eliminated. Why can it be eliminated? Because you know where is the source, so you can eliminate them. Here you do not know the source, so you cannot eliminate the error. Okay, so if you know where the problem has happened, you can solve the problem. If you do not know where is the problem, you cannot solve the problem because you don't know what is the source. Okay, this is the fourth point. And the last point is fifth. These errors are also called as systematic error. These errors are also called as systematic error, and these errors are also called as random error. Okay, again very important thing to remember. Determinate error are called as systematic errors, and indeterminate error are called as random error. I just give you an example of indeterminate error as a host, a gooth. Okay, so you do not know from where that gooth has come, whether that gooth is what it is, you don't know. Okay, so it just comes anywhere, anyhow. So those are indeterminate error. Determinate error means you know what it is, from where it has come. So since you know what are from where the determinate error has come, you can differentiate them or differentiate them. So in the next slide, we are going to see the types of determinate error. Determinate error are of four types. Based on the source, you can classify them in four types: instrumental error, methodic error, operational error, and personal error. These are the four types. Now, how to remember these? I just give an example. MOP. I had a friend in my college. His name was Prakash. So whenever somebody asked him, "Who are you?" he used to say, "I am OP." So remember, I, instrumental error, M, methodic error, O, operational error, and P is personal error. This is how you have to remember these four types of error. Let us see each one of this one by one. The first error which we are going to see is instrumental error. What are instrumental errors? After studying this, whenever the student work in the lab with the instrument and they commit any mistake, what do they say? Madam, instrumental error. हमारा mistake नहीं है, instrument का mistake. Okay, so blame is on the instrument. बेचारा गरीब instrument. Okay, so it cannot say anything, so you put all the blame on the instrument, but don't do this. You should know the actual meaning of instrumental error. So what are instrumental errors? First thing is least count. Okay, it is because of the least count. For example, you are working with a burette. Okay, and on the burette, the minimum least count of the burette is 0.1. For example, 10, 10.1, 10.2, 10.3, like this the reading goes. Okay, or above this you can say 9.9, 9.8. Fine. Suppose my actual reading is 10.123. You cannot get 10.123 in the burette because the least count itself is just 0.1. Okay, so I cannot get 10.123 because the least count is 0.1. So that error will remain. It is not your mistake. It is because you are using a burette whose least count is 0.1. So if you want to get the answer in 3 digit after decimal, you have to go for a proper sophisticated technique. So this is about the error, instrumental error, which comes because of least count of the burette. The second type is when you are operating in a wrong range you are working. Okay, wrong range. Now suppose pH meter you all have used. pH meter is supposed to work in the range of 1 to 9. Okay, it gives you perfect reading in the range of 1 to 9. But if you take the reading beyond 9, more than 9, pH is more than 9, you are taking reading, or less than 1, you are taking reading, then the instrument will give you error. It will not work efficiently. Okay, it will not give you 100% correct answer. This is because you are working in the wrong range. Okay, this error again will be called as instrumental error. So I hope you have understood. Whenever you are using an instrument and because of the instrument the error arises, it is called as instrumental error. Next type of error is methodic error. Now, what is methodic error? Methodic errors are the error associated with the method of analysis. It's not your mistake. It's not a mistake of the person doing the experiment. It is mistake of the method. Whenever you do that method, their error will come. Okay, so here we have 3 examples. First, it is precipitation of a salt in gravimetric analysis. Now, what happened in gravimetric analysis? In gravimetric analysis, you take a solution. Okay, in this solution, this is solution of your metal ion, and you put a precipitating agent. Suppose you have nickel and you are adding DMG. Okay, so what salt is going to form? This nickel DMG. Correct, nickel DMG is going to form, but the solution is saturated uh, solution of nickel, means too much nickel ions are there. It is not possible to remove all the nickel and form nickel DMG. Okay, some nickel will remain in the solution. Okay, so even if you do anything, this error will arise. You will not get 100% nickel. What answer you get it will not correspond to total amount of nickel. Okay, so this error will remain always because of the method. So whenever you follow this method, this error will be there. We don't do anything for this because we have already accepted that this error will be there whenever we do this method. Okay, the second type is excess of titrant. Now, what is the meaning of titrant? What is the meaning of titrant? I've already explained in some previous video. You can watch that. I've also explained what is endpoint and what is equivalence point. So what is endpoint? Now suppose you have taken here in the burette, you have taken NaOH. In this you have taken HCl. You have added phenolphthalein indicator and you are doing the titration. So now our NaOH gives color change from, NaOH doesn't give color change. Phenolphthalein gives color change colorless to pink. In basic medium it is pink, in acidic medium it is colorless. Okay, so when you have HCl here it is basic, correct, medium is acidic. So in acidic medium your phenolphthalein is colorless, no color. When you are adding NaOH, the solution is going towards basic. Fine. So exactly suppose this is 10 ml, 0.1 normal. This is also 0.1 normal. What should be the reading? Obviously N1V1 equals to N2V2, the reading should be 10 ml, right? So now at exactly 10 ml, what will happen? Exactly 10 ml, the solution is neutral. At exactly 10 ml, the solution is neutral. So my phenolphthalein is not going to give color change because it will give pink color only in basic medium. Correct? So in neutral medium, it will not give color change. You just add one more drop of NaOH and your solution will turn pink. Okay, so this error, this is called as the equivalence point. Equivalence point is this, at which your reactant has completely reacted with the titrant has completely reacted with the titrant is the equivalence point. Is the equivalence point. And what is end point? End point is where one more drop you add, you see the color change, that is called as the end point, which you can see and which you note down. Okay, so this error will always be there whenever you are doing titration. This is second. Whenever you are doing titration, this error is there and we don't do anything for this because we know we have accepted there are two different concepts of endpoint and equivalence point. Third example I give you is incomplete conversion. In some experiments of gravimetric analysis, you have Fe solution. From this Fe solution, you precipitate FeOH thrice. This FeOH thrice, you heat it, you burn it, you make Fe2O3. Okay, and this you weigh. Okay, you find out the amount of Fe2O3. You weigh and you find out the amount of Fe2O3, and then you back calculate that how this was the amount of Fe2O3. How much would be the amount of FeOH thrice? And how much would be the amount of F. But if this reaction is not complete, then whatever you do by vector iteration to get Fe would be wrong, because this reaction is not complete. This is incomplete. Okay, so the error would always be there irrespective of how much precaution you take, because this is error associated with the method. So I hope methodic error is understood. Next type of error is operational error. Now this operational error are the errors associated when analysis is carried out. Who do the error? You do the error. The analyst do the error. They are the error introduced in the analysis of the sample by the analyst when you do the method. The ignorance, negligence or indifference on the part of analyst leads to operational error. Now operational error we all do in the lab. What you all do? Various type of errors you do in the lab. To do the color change. Okay. So last drop of pipette. Whenever you are working with the burette, pipette, you take the solution, you suck in the solution and you throw the last drop. You blow out. Jaldi rehti hai, ghai rehti hai, right? So you blow out the last drop of the pipette, which is wrong. The pipette is made in such a way that you don't have to blow the last drop. Blowing the last drop of a pipette is the operational error. Okay. Now improper recording. Suppose you got the answer some on the instrument and your friend is talking to you and you wrote something else. Okay, improper recording is also an operational error. Another error is operational error example is weighing hot crucible. This type of error arises hot crucible. This type of error arises because our students are always in hurry. Right, you are in hurry, you don't have time. So what you do, you weigh hot crucible. But that is an error. You cannot weigh hot crucible, it give you different answer. Okay. Then suppose you are doing the titration and you split some solution, just little. You are doing shaking, doing the titration, shaking and little solution came out. Okay, this is an operational error. And so what do? जितना गिर गया उसका 0.1, 0.2 ऐड करके our students एक ड्रॉप देख के बोल देते हैं कि कितना सोल्यूशन गिरा है, right? So you do the manipulation, you get the answer, you do not repeat the analysis, correct? So that is called as operational error. You should not do that. Slowly, carefully do the experiment. So splitting the solution is operational error. Then committing errors in the calculation. You have everything in front of you. The beauty of chemistry is that a manual is allowed in the lab. So in the lab you have the manual, you have the calculation in front of you, but substitution mistake, some mistake, calculation mistake, our students don't know how to use the calculators. So that mistake is operational error. Improper reading of the scale of the instrument is error. Okay, so if this is the burette, this is reading 10, here is 9, here is 8. Suppose I got somewhere here. So student read, this is 8, this is, this is 9, this is 11. So suppose you get reading somewhere here, the reading would be 10.5 not 11.5. Correct? So there is a way to read the readings. Student read the readings wrong. Upper meniscus, lower meniscus, color solution, colorless solution. Okay, all these mistakes are done by the analyst and these are called as operational error, which you do are called as operational error. The last type of error is personal error. The personal error is one example is color blindness. This is personal problem. Okay, so person cannot differentiate between red color and green color. Personal problem, color blindness. But mostly this personal error arises because of the biasness of the analyst. Okay, the biasness. What's the meaning of biasness? Biasness means I got some answer, but I'm not writing that answer. I have something else in my mind. Okay, so that I write down. What the students do, which you should not do, wrong practice hai, obviously. You see the answer of your friend, answer of second friend, 10.1, उसका आया 10.3, उसका आया 10.5, तो obviously मेरा भी 10 में ही होना चाहिए ना. Okay, so I don't write what I get. I got reading 5.1. मेरा 5.1 कैसे आ जाए? Correct. So I take the average and I write down that only. I don't write on my reading. So this is biasness. Biasness means you don't write what you get. You write down what you think. So this error is called as personal error. Your answer, your observation should always be objective and not subjective. Okay, not subjective means not dependent on anything. Biasness for an observation is the most common type of personal error associated with almost all the analysts. Therefore, it is necessary to remove the personal bias and record the observation objectively. Okay, so this is all from my side, all about thermochemistry. If you have any doubt, please write down in the comment box or you can directly ask me in the class. Do like, share and subscribe. Thank you so much for watching.